So linear algebra, it also plays a role in recommendation systems and search engines. So linear algebra is used in recommendation systems and search engines. So modern web platforms, they rely on matrix operations to organize the internet and predict what you will like. So in search engines, matrix operations are used. In recommendation systems, operations are used. So if we talk about search engines, and in search engine also, uh, we are mainly emphasizing on the page rank. So in search engines, especially the page rank, Google, it represents the web as a massive adjacency matrix where links between pages are entries. So companies like Google, like we all use Google search. So Google search, it represents the web as a massive adjacency matrix wherein the entries of these matrices is the link between these web pages. So finding the most important pages is mathematically equivalent to finding the dominant eigenvector of this matrix. So Google search or any search engine you consider, if we are talking about the PageRank algorithm of Google search, it makes use of the adjacency matrix to represent the web pages. So the entries of adjacency matrix is the links. So wherever there is a link between the web pages, that will be an entry in the adjacency matrix, and we find the most important pages mathematically using the linear algebra using the concept of eigenvector. We find the eigenvector of this adjacency matrix which will give us the most important pages, and hence we are making use of linear algebra here. Similarly, in recommendation systems also, we make use of linear algebra. So recommendation systems, you know that we have seen recommendation engines like any e-commerce platform. If you visit, it recommends you some products. If you explore an OTT platform like Netflix, it recommends you movies. If you visit LinkedIn, it will recommend you connections to follow. So that is what recommendation engine is. So in recommendation systems, like services like the Netflix, it uses collaborative filtering. So companies like or the products like the Netflix OTT platform which we use, it makes use of the collaborative filtering, which involves factorizing a large user item matrix into small feature matrices to predict missing ratings. So this is called as matrix factorization. So basically in collaborative filtering, Netflix, what it does is that it uses the user item matrix, like based on the past behavior of the user, what items the user preferred. So making use of the user item matrix, it factorizes a large user item matrix into two smaller feature matrices. So these are like the feature matrices. So we have a matrix called user feature and an item feature. So a large user item matrix is factorized into a user feature matrix, a smaller user feature matrix, and a smaller item features to predict the missing ratings. And here also we are making use of matrices, and hence we are making use of linear algebra. So now we are realizing the importance of linear algebra, that linear algebra not only in artificial intelligence but also in recommendation systems and search engines, linear algebra plays a very big role.